So if you're using these synthetic materials to recreate things, are you conflicted by that? What do we do about the human soul? Where does that come into play?
Almost, everybody that weighs in on this says there's at some point where life begins, right? Sperm and the egg are alive in a certain sense. They fertilize, they make an embryo. It's still alive. It gets more and more complicated, and it gets more and more alive, more and more sentient. Eventually it goes to school and makes more sperm and egg. And at some point it's always alive, it's always human. It's just that at certain points it's more sentient than at other points. The synthetic biology, the synthesis from scratch is just beginning. What we really do, more than synthesis by scratch, and in fact it's more useful, is modification. So in other words, you modify a cell to make it do something new.
Do you want to recreate a human from scratch?
I mean, we're coming pretty close to making a bacterial cell from scratch that has a new genetic code, and the reason is, the reason you're doing it helps you inform whether you're crossing some line. And so the reason we're doing it is to make a cell that's resistant to all viruses. By changing the genetic code, you can make it so that the viruses coming in and say, whoop, what happened to the genetic code? It's all messed up. And then they not only can't live, they can't reproduce, they can't even mutate and become resistant the way a virus would if you gave a new drug or something in the wild.
I mean, I don't understand biology at that level to be able to know this. So does that mean that the virus could then go and become a super virus, or you're saying it would just bounce off? And
you've created a super cell that is resistant to viruses. In principle, you could make a superorganism. You can make, agricultural species, plants and animals that are resistant to viruses. You might be able to make human cells that are resistant to viruses. But you haven't fundamentally changed it. Whether you've written it from scratch or whether you've modified it, the only thing that's different is the thing that you tried to change, and maybe some unintended consequences which you need to study, but it's really still the same living thing that you started with,
The sensational question for me to ask you right now is, do you believe in God? Are you playing God? Where does creationism fit in? But what I really want to know is, what public opinion do you want to change to help you innovate?
Well, some of the controversial topics that are either religious or almost religious in nature, that is to say, even things like global warming and genetically modified foods become religious in that they stop listening to the facts.
Right.
Or they stop having the facts as their top priority. They may listen to them on the hopes that maybe someday they'll agree with them, but they're not really actively participating in the experiments that could prove whether GMOs are safe or not, or whether global warming is an immediate threat or a distant threat. Right. And I think in some of these cases that gets solved with time. In other words, Galileo eventually was completely accepted by the same religion that rejected him. Right. And that just means, and in science we reject things and that turn out to be right, and then we eventually accept them. It's just the time constant is a little different. But if something is truly valuable for society, if they can see, Galileo's version of astronomy was eventually valuable in terms of celestial navigation and longitude and all that stuff, and you get a more accurate physics. If evolution in the lab becomes valuable and we can make really big changes via lab evolution, then if you work in an evolutionary lab, you might accept evolution as a real thing, because you do it with your own hands and you can see that it's true. But until then, there's more heat than light. I mean, if it doesn't really matter to society whether evolution is true or not, why does it have to be the top agenda item for education? I mean, there's so much that students have to understand, so many concepts, not facts, but concepts, way to manipulate facts. Teach them the scientific method. Teach them how to be skeptical of statistics. Teach them how to make public policy decisions and corporate decisions based on a fact-based method. But the fact-based method is very, very hard to apply to astrophysics and to ancient evolution. So start with things they can apply it to in everyday life.
How do I give my, and people listening and reading this, genome to the Personal Genomics Project? How do I get involved?
So if you're interested in
signing up
and learning more about it and deciding whether it's for you and your family, personalgenomes.org, or just Google personal genomes and it'll pretty much up there near the top, and it'll lay it out for you and you can sign up. And
am I sending you my spit? Am I coming to?
Well, so we do spit for some things. We mostly use blood. It's a higher quality genome. We also sometimes use skin if we're establishing stem cell lines. But but we have blood drives in a certain sense in multiple cities. And we also need money. I mean, this is not, we provide it as a free service, but ultimately somebody has, it's all funded. We have a lot of volunteers that work on the project, as well as, of course, the volunteers that donate blood. And we have some rich friends that occasionally give us a little money. But it's extremely, I mean, we could scale this up much faster and much more, help a lot more people if more people would contribute.